So these are the first 20 on your pre-test, test number 5. On the calculator portion, again, don't forget that you have this to look back at any time. So problem 1 is basically asking you where is the steepest part of any one of these segments, which one is the steepest segment? That's what I should have said, steepest segment. So from 2010 to 11 is that. That would be the greatest rate of change. The smallest rate of change would be where you have the flattest segment. So you see from 2003 to 4 would probably be that good answer there. Or actually from 2006 to 7, because that's going downhill, which is a negative rate of change. So 2006 to 7 would be the best answer, and 2003 to 4 would be 0. So understand all parts of that question can be asked. Problem 2 is getting at the y-intercept. So go backwards. This is a linear function. So 0, and so you're dropping by 2, and this is 8, so you would just go by 4. So if you go by 1, this goes by 4, then go by 1 again, this goes by 4. You need the y-intercept, and then you can just do a slope calculation to get the slope. So I picked the 20, these two here, 21 minus 13, y2 minus y1 over x2 minus x1, and that's 4 for the slope. You have your calculator, by the way, now, so you could try these in and see which one of them produced the table. Number 3, so 2.5 ounces is to 16 ounces. And we want to do that. That's for each muffin. So we want 48 of those. And so that would give you, so this is the pounds in one muffin times 48 of those. So you would need 7.5 pounds of chocolate to do that. Okay, so number 4, divide by 3. You want the value of C plus D, so that's all you need to do. Number 5, you want to subtract those fractions, 14 over 10. That gives you the difference for 1. And then so for 100 pounds, you would multiply that difference by 100 to get the difference in the weight on each. Okay, so problem 6, you have this system here, and the easiest thing to do is, since you have kind of this automatic canceling going on here, is to multiply this bottom row by -1, but let's discuss setting the system up first. So this is just what I call one set of 3 values system. So notice all those money values go together, and then a total line. So an equation that represents the total of what you're talking about. So the total is 11, x plus y equals 11. And then run a negative through the bottom, and then the y's will drop under addition. So that'll allows you to solve for the novels, the number of novels. You can expect some type of linear system to be on this. Okay, another linear function type here. Okay, so n is the rate and b is the start. Okay, it increases membership by a total of n businesses per year. So anytime you see the word per, that's the rate part of whatever it is you're talking about here. We're talking about a linear type of model. So that would be the slope. And then the starting, there were B businesses and the DBA at the beginning. So this is talking about a linear increase. The SAT loves linear functions and a little bit of quadratic functions. So nx plus b on that. Okay, which of the following is an equivalent form of this? So Oh, yeah, just evaluate. So notice that the number on the end here is different in each one. So what I did is instead of taking this whole product out right here, I just said, all right, imagine it this way. We got to square it. And then we have to minus this. So you know on the last part, you have to do negative, that's a point, sorry about that. 2.4 times negative 2.4 on the last part of the FOIL. And then you have to add 6.4 because that negative runs through there. So just do the last part of it. A lot of times that's all you need to do in a problem that's looking like, you know, this is a lot of work. So if you did the whole thing out, it would be a lot of work. But if there's any way that you can do a piece of it, a lot of times just the front end, but notice the front end you have two that are the same with the negative 2.95x squared. So the back end is the best way on this one. Problem 9. So here you're comparing ratios of similar things. So 1 mile is approximately 1.6 kilometers. So we went 40 kilometers to 42. So 1.6 kilometers in top, 2 kilometers here, and then 1 mile on the top and X miles in the bottom here. So you just need to stay consistent this way with this. So 1.25 miles is this bottom. And that's how I generally teach when you set up proportions to keep the top and the bottom consistent. So again, 1.6 kilometers here, 2 kilometers here, 1 mile here, X miles there. And then do a cross product and then divide by 1.6. Okay, problem 10. D equals M divided by V. And here we go again with eliminating fractions. So multiply by V on each side. And that will give you the result of what M is. They will test you with eliminating fractions. I promise you that. So if we solve this for y, this is what we're going to get. And so if we want a slope of a line perpendicular to this, the rule is that it's an opposite reciprocal. If it was parallel, so those two are opposite reciprocals. If it was parallel, it would be the same slope. The problem is, okay, it's not just saying what are your slope choices here. We need to figure out which one of those has a slope of -3/2. Well, a little bit of common sense tells you that it's probably going to be A. So I just chose A to solve for y so that you could see the slope as -3/2. Just because it's the only one that has the 3, 2 as the coefficients there. Okay, so system of equations has solution xy. What is the value of x? So again, you want to solve for y in both, eliminating fractions, multiply by 2, take the bottom, multiply by, or I subtracted x first, and I multiplied by -2, left to right, so that makes just a 1 there, and then a +2 there, and a -4 there. So solve for y, notice the eliminating fractions again. It's a huge deal. Set them equal to each other, and then solve, and you get 6 for x. And so if you wanted to get y, you'd have to go back up to the second one, put 6 in, 12 minus 4 would be 8. And there it is, y is 8. You knew that from the top one. Problem 13. So which one of these is true? And literally all you can do, and so of course they put it fourth, so there's be a lot of subbing here. You need to try each one in, and both of them have to work. Both of them have to be true. Alligator has to be consuming the larger number in the end, I guess is the best way to think about that. So D is the one that works. That's a lot of work. It's an easy problem, but it's a lot of work. 14. Okay, so the problem, which of the following is close to the probability that the selected surgeon is an orthopedic surgeon whose indicated professional activity is research? So both of those have to be true. So 74 is that number over the total of 607. This is called a two-way table. So you have two things this way, two things this way, and you're trying to match up those things with questions. There's a lot of different questions that can be asked of that two-way table. So 15, based on the results of the survey, which of the following statements must be true? So of those surveyed, you took a sample of 1,000, 78% responded that they were satisfied with the quality of air in the city. Okay, so 780 of those people said they were satisfied out of the 1,000. So of all adults in the city, 78% are satisfied with the quality of air in the city. That would not necessarily be true. If another 1,000 adults, 78% would report that's not necessarily true either. If 1,000 adults selected at random from a different city were surveyed, then 78, that's not necessarily true either. So there's a lot of things in statistics. If this was what's called the normal population, then it might be true, but you can't. I mean, if it's a large city, you're only picking 1,000 people. You know, you might pick the people that are in the wealthy part of the city that's located away from the industry. So yeah, there's no conclusion there that you can. The only conclusion you can draw is in that sample, 780 of the 1,000 said they were satisfied. All right, problem 16 is dealing with the species of tree and then the growth factor here. Okay, so which is the approximate age of an American elm with a diameter of 12. So we're going to do 12 times its growth factor of 4. Pretty easy on that. I love how they always split these problems. Okay, so the scatter plot gives the tree diameter for 26 trees. The growth factor of this species is closest to that of which of the following species. So I just picked a point I could see pretty easily, like 1290. And so it's 12, this is the diameter of the tree, this is the age. So what's the, what are you multiplying by 12 to get 90? That's by 12 to get 90, that's 7.5. So you got to look back which one has 7.5, and that's the shagbark hickory. Okay, and then still another question. If a white birch tree and a pin oak tree each now have a diameter of 1 foot, which of the following will be the closest to the difference in inches of their diameters 10 years from now, if 1 foot equals 12 inches? So here's the idea. So we have to figure out how old they are now. So each of them has a diameter of 12 inches. So multiply by their growth factors. This is their age. So 10 years from now, you're going to add 10 to each of those and then divide back by the growth factor. And so that would give you the difference in their diameters. That's a hard question to know to do that. But you do get 1.3 inches. So there's the SAT loves, okay, here's a chart, and I'll ask you a couple of easier questions, and I'll ask you a hard one at the end of the chart. So a couple more in this round. Equilateral triangle, here we go with the first page stuff. Let me see if I can find it here without taking forever. Your 30, 60, 90 rules. It's right here. Look back at that. So we know this because this is 30 and this is right here. So that's 90, that's 60, and that's got to hit at the midpoint if that's the case. Making these 12, this will be 6 because half the hypotenuse, okay, as you see here, it's a ratio of 2 to 1. And then times the square root of 3. So what is the length of AD? So 6 is going to be that length. Pretty simple to do. Okay, which of the following is a function of time from when the wheel began to roll? So what is this describing as you're focusing on the dot? So here's the height of it. And as time goes by, so it rolls and then it goes down to 0 and then it comes back up. Then it goes down to 0. So it has to be the distance of the mark on the rim, from the ground. The speed at which the wheel is rolling. So I don't know if they said it's constant. Yep. So constant speed would just mean you would actually, if this is the y-est distance, it would just be a line like this. So you can, again, go through each of these, and it's definitely not going to be this up and down. You have to have something that's got a positive quantity and then hitting 0 again. So this is the only one that will do that. So those are the first 20 on the calculator part of test number 5.